In this video, we'll look at using product rule. So the first question is y equals sine x times 2 to the power of x. When you're using product rule, you take the derivative of the first thing. So in this case, the derivative of sine x is cos x. And we multiply it by the second thing without doing anything to it. That is, we start by just doing the derivative of the first thing times the second thing plus, and now we write the original first thing, in this case sine x, and we take the derivative of the second thing. What's the derivative of 2 to the power of x? It's just ln 2 times 2 to the power of x. So again, how did I do that here? I did sine x derivative cos x times the second function plus the derivative of the second function, this is the derivative of 2 to the power of x, times the first function. So it's made up of two pieces. One of the pieces has a derivative, the other is the original, and then the second piece, the original, the derivative. And there isn't much we can do there. Sometimes I like when you simplify it, we can write that as cos x times 2 to the power of x. It's not really simplifying, but generally I like to move some of these things out front. We can move this ln 2 out front and put this 2 to the power of x out front and then sine x. But it really doesn't matter. As long as you've got all those pieces together, you've got the derivative. For this question, a different function, and I wrote it with function notation, I want to show you that product rule works. That is, what we're going to do is take the derivative of the first thing times the second, and then the derivative of the second thing times the first. So, what's the derivative of negative 9x cubed? Negative 27x squared. Bring the exponent down, subtract 1 from the exponent, and whatever you brought down, times that on the coefficient. So you get your first derivative times the second function, plus rewrite the first function times the derivative of the second piece, which in this case is 2x squared, and the derivative of that is 4x. But with this one, unlike the previous one, this one we actually can do some simplifying. What's negative 27 times 2? Negative 54. What's x squared times x squared? Add the exponents. You get negative 54 x to the power 4. And for this question, you get negative 9 times 4, which is plus negative 36, or just minus 36. And x cubed times x, add the exponents, you get x to the power 4. So, now like terms, they both have x4s, so we can subtract 54, take away 36, is negative 90 x4s. So the point of this was to show you, look, if instead, you might have noticed, here let's call this check. You might have noticed, look, I can rewrite this equation by just multiplying in the beginning. It's negative 18 x to the power 5. And then bring the exponent down and multiply it by the coefficient. Negative 18 times 5 is negative 90. Subtract 1 from the exponent. So a smart question would be, why would anyone do it this way? The answer is you wouldn't. It would be much faster if you saw I should just multiply the original function together before I take the derivative, when I should probably write here that I took the derivative, f prime at x, and look at the f prime at x we got here. Same one. Except the whole point of me doing this question was to show you, look, product rule works because I did it the long way, and when I checked it using the short way, that is, multiplying the two components of f at x together, I got the same derivative. In other words, product rule works. You can just take the derivative of the first piece times the second piece, and then the derivative of the second piece times the first piece. That's how to use product rule.